Hey guys, Kristian Mischke here. We're going to be going over data and variables. Okay, let's get into it. So we're going to go over the data section. We have to make a variable or make a list. Let's make a variable. Let's call it, well, let's just call it var, short for variable. And here we are. We have this little circular shape, and we got these 4 block shapes right here. Let's just set up our program with the flagged clicked, and go back to data. We can set var to any number we want, and we type it in here. So it could just be something like that. When we click the flag, it sets to that. We can set it to text, so like hello. Click the flag, and it says hello. We can do a true or false value with caps or not caps, but true. And we can set it to false if we want. You can set variables to anything you want, which is really amazing. You can change the variable, but only if it's a number. So if it's like 2, you can change it by 1, which will increase it to 3. So if I double click on this, it'll perform the operation. Now it's 4, now it's 5, 6, 7, so on. Okay. We have show variable and hide variable. I'm not going to go over these because that would involve more than it looks like it would in processing. But I'll go over these definitely. Now you'll notice if we set this to text, a bunch of random text, we run this, it's NaN, which means like not announced. It's not possible. You can't add 1 to tiazdigazgik. That's just not possible. So that's not the right type, okay? And we're going to be going over data types in processing. Now in Scratch, we don't have data types because we just have variable. You can set it to whatever you want, literally. And that is very similar to a lot of programming languages like JavaScript especially. This reminds me almost exactly of JavaScript. And it's also like some other programs like Ruby or Python and stuff like that. In processing in Java and the C type languages, it's a bit different. So I'm going to set up the program with a void setup. And let's give it a size of 600 pixels by 400 pixels maybe. Okay, we run that, we just get a blank screen. Since I'm running on a second monitor, it keeps popping up down here, so I'll just drag it up. And there it is. Okay, so we haven't done any variables yet, so let's start it. Now you can put variables above the void setup, and this is common because as you'll see in a moment that the variables won't carry through, but I'll get to that in a minute. Okay, so to make a variable, you do not type var and then the name and then equals something, okay? You don't do that, okay? That would be more like a JavaScript application. Here we have data type name equal, okay, you can just put it like that. Okay, here, comment this out just for structure. Or you can do data type name equals initial value. Like so, those are the 2 ways. Okay, and you just fill in these with whatever you want. So here's an example. The first data type, a very basic data type, is called an integer. INT. That stands for integer. It means a whole number. So it means like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever, like that. But not like 1 point yada yada yada. There's no decimal point. It's always a whole number. So integer, this replaces data type. Okay, that's done. Then we'll do space, and then we'll have the name. What should we call this? Age. We call it age. Okay, so this is how old someone is. Okay, then we could just leave it like this, and we'd have our variable, but it wouldn't have any information in it. But it might, because some types, like integers, might be automatically set to 0 right when you make it. To test this, let's go into our setup. Let me tidy things up a bit. Okay, right here, let's do a print line, and we can literally just type in age. So we set it here, or well, we create it here. We have an integer called age, and we can access it by just typing in the same word, age. So it'll print out the age in the console below. Run this program. See that nothing happened to this screen over here, and we have 0. So the initial value of an integer is 0. Okay, I can set it right away. I can do equals 56. That's a old age. Well, maybe not too old. Okay, here we go, 56. So we can see that it equals 56. We can change that to something else, like 1. Run it again. Nothing on here. It's 1 down there. Okay, you get the hang of it. Integers can be negative. We can have negative 100,000, 1,000, whatever. There is a limit to integers. I'm not exactly sure what it is right now, but you can get them pretty high. Now, if you ever do exceed the limit of an integer, which is like a couple million or something like that, there's a variable called a long. And these numbers can get really big. So you can just do like big number. Oh, there cannot be spaces in the name of the variable. You can do underscores, but when you have 2 words in a name, this is the way I do it, and it looks pretty neat. You just do the first one lowercase, and then the second word would be uppercase, the first letter, that is. So big, number, like that, equals like boom. Let's see if that works. We can type in big number right here. Okay, I think you have to type in an L. Yeah, okay. So if you're making an int, you just type in the number, and integers can be 0 too, so you could just put in 0 like this. And you don't have to type in anything after it. But if it's a long, you're going to type in an L after that. And in some programming languages, it highlights this as a different color. So like this L will be like blue or something, or green or whatever, and that way you can see it better. So if it's a long, L stands for long, and that means the number can be huge, okay? Like this big, whatever number this is. So we can just leave that there. And you saw that I put big number down here, so it's printing that now. We can print both of them, why don't we? I'll just copy that and put it right above it and put age in here. Okay, next data type. Float. This might sound funny, like floating on water. What's this? Well, a float is actually a floating point number. So we can do like pi, even though there is something for pi already, but I'll just show you right here. 3 equals 3.14159. Okay, that's as far as I know. And it can equal a decimal value, so it can have a point and then a yada 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 after it. And we can print it out too. Just copy this, paste it below. Why did you do that? Okay, go backspace, there we go. For neatness, we can just type in pi. Run this. Now we get the 0, which is from the first one, then print the second one, which is the long, and then print the float. Okay, looks good to me. Also, say, not particularly in this language, but if you just type like 2, you might want to put an F after it, so you know that it's a floating point number, and it changes it to 2.0. But if you see, if I backspace it, let me correct me if I'm wrong. Okay, it still is 2.0. So this programming language automatically does it, so you don't have to put an F behind it to make it float. But other programming languages you do, which you will see when I do tutorials for C# way later. So we can set this to 3.14159, and that's our floating point number. Now, I'm going to do one more. It's a couple more, but this is another number called double. I know this is a lot to hang on to, but double come up with a number, man. Height. Nope. Let's call it something else. Let's call it. I can't think of a number. My goodness. Radius. How about that? We can just do like double radius equals. And by the way, yeah, this you want to name this to be convenient, just like you would name your variables here. I forgot to mention that. So double radius. A double is the same thing as a float, except you can have longer decimals after it. So you can do like 3 point, I think this much. Let's see if that overflows it. No, it doesn't. Okay. Well, you can have a lot. Radius there, and you can put a D after it. Make it a double. Yep, and I think we can add a bunch. Okay, you will notice that it stopped at 8074, but this ends at like 1456. So 8074, is that where it stopped? It did stop right here. Now that's kind of weird. So doubles act a little bit different. I guess you can only have this many, and it will round it in some way so that it'll be right. So you can only have this many decimal points after it, but it will round it automatically. That's interesting that it's rounding the last number down. Don't know what that's up to, but you can store doubles in here. Double does take up more memory than float, so I would recommend, let's see, these are the, you're going to use this a lot. Used a lot. This is used quite a bit. This not used as much, but it is still used. And this, I don't ever know when to use this. I don't use this. I don't use this. I just use floats because mine, I don't really care if it's so precise. But if you do need more decimal places, then this is what you need. So maybe for like some sort of calculator, you'd want to use doubles and not floats. And yeah. Okay, so these are our number variables. Integer and float are the big one. You're gonna want to get used to those for sure. Okay, let's move on. So now we can set numbers like this. We can literally set them like that, and in processing, we can set them. We can do int age equals this. Okay, before I get on to the next type of variable, I'm actually going to introduce something. So I'm going to do an example with age. Okay, so I set it to 0, then I print it out right here. Okay, now below the printout, I'm going to do age equals 5. Okay, now you notice that I'll put type integer right here when I set it, when I create the variable, but down here I do not. So when you want to use it, like here, or reset it, or use it in some other way, you do not put the integer, because this is only for creating new ones, okay? So now we have it down here, and if we print it again, we should be good. So if we run it, you'll see we have 0, which is the first one, so that's age. This is age. Then we have big number, then we have pi, then we have radius, then we have age again. And the program runs just like a Scratch program, so it goes from top to bottom. So that's why it was printed, then it was set, then it was printed again. Okay, so that's that part. Now, there are still a few more things with numbers. Instead of equaling it, like setting it to 5, we can do plus equals. Now this is a bad example because this is set to 0, so let's set this to another number like 3. So in the beginning it's going to be 3, then it's going to print it out, then it's going to plus equals it to 5. So this means add 5 to it. So it's basically change by 5. And here we are. 3 plus 5 equals 8. Bingo. You can also do minus equals to subtract 5. I'll show you that. And as we get into the more math functions, I'll show you more of these, what these mean. So here's minus 2, because it was 3 minus 5 equals -2. We can do divided by equals or times equals. I'll get into those in another lesson. Okay, so you can do that for any of these, really. Okay, next data type. Okay, these are numbers. Okay, now I'm going to do text. Now this is probably going to confuse you at first. It's called string, and it is with a capital S, especially in this language particularly, and some others. So it's a capital S string. It's just a line of text. A string of text is what they call it. So we can do like name, or cat's name. Notice how I uppercased the first letter here, and if I had more words, then I could do like cat's beautiful name. Beautiful. There we go. Like that. And you can make these as long as you want. So yeah. So string, let's just shorten this so it's easier to type in. Okay. Cat's name equals, and you use quotation marks. If you remember from the hello world, we had quotation marks that said hello world in it. So we could do cat's name equals battle cat, like so. This is a string. This is a piece of text. You can have letters and spaces and all sorts of stuff in here. You print line, let's print it all the way at the bottom. Print line our cat's name. Here we are, battle cat, like so. And notice how the quotation marks aren't used down here. It's only used to set it. This is how you know that it is a string. It is a piece of text. So you have to have these. Other languages, you can just use the single ones, like this. I'm just gonna test it right now to see if it doesn't work. Okay, that's in like JavaScript that particularly has it, but in Scratch, in processing, you just have two quotation marks right here. So that's text. Let's just make some more strings real quick. String first name. Oh, okay. I'm gonna leave that lowercase. I don't know why I did that. First name, like so, equals. Okay, my name is Kristian, like that. Boom. Okay. Let's do string last name, like so. And string. So see how many variables we're stacking up. It's okay to have a bunch. Some programs will have tons. Okay. First name, last name, and then we'll have first and last name. Could just call it full name. Why am I doing this? Okay, full name. Here we go. So we can actually add strings together. So we can literally type in first string. Well, first of all, as an example, I can type in. We're going to want to put a space in here. Plus, like so. Now I'm not going to print the first two because I don't have to. I don't want to. I'm just going to print the full name. Like this. I run the program. Here we are, Kristian. So you see how it adds Kristian and Mischke together. So you can add strings together. In the same way, you can add variables together, and if they both happen to be strings, you can do first name plus last name. Now, you'll notice that it might not look the best right now because my name will be smushed. I want to fix that. We're going to have to add a space and then add that. That'll look better. Ta-da. Okay, so you can add strings together. And you can use the variable name right here to set another variable. Fancy. Okay. Let's go over another data type. So this is called Char, which stands for character. Okay. So middle initial. So this is a char, which is character, which is one piece of text, and you do that with these single quotes. You put it in here, so you can do like A, B, C, D, etc., etc., etc. Okay, so we can set it like this. So it can be K, and it can be uppercase, lowercase, whatever. So char is just one character, and this can be useful in plenty of cases. So yeah, so I could move full name down here, boom, and then paste it down here, and I could add a space, and then I could add, you can add characters, middle initial, boom, plus space, okay, and we can also make this a character if we want, just a single space character, whichever way you want. So yeah, characters are compatible with strings, unless you spell them wrong. Initel, whoops, okay, spelling errors. If something says, cannot find anything named middle initial, which was right here, it was called middle initial, and this was called middle initial, you have to be sure that they're spelled the same. If they're not spelled the same, then it won't recognize it, so just get that down. So here we have Kristian Mischke. Boom. Okay, that's strings and characters. Next, logic. Ho ho ho. So there's this guy who's called he made this. He's the one who came up with these. It's basically all of computers are made up of zeros and ones like this, right? In different ways, and you don't see that on the outside too much unless you program in binary. That's what it's called. And 1 means true and 0 means false. 1 is on, 0 is off. Okay, and these are called Booleans. The guy named Boolean, I don't know his full name, but he created these, and in this programming language, Boolean, you just type in Boolean like this. Sometimes it's just bool for short, and so the name, it can be like light switch is on. So we can name it whatever we want, just like any of the other variables. The data type is just Boolean. Okay. We can set it to true or false. Those are the two values that it has. If you don't set it to anything, it will be null. And null is the same as NaN, like as you saw here when I typed in text and then tried to add something to it. NaN means it has no value. I don't know what to do with this. Like, the program's kind of like, I'll just, I can't add ASDF to add 1 to ASDF, so I'll just give you not applicable, no value, just nothing. Answer is nothing. You can't do anything about it. That's its way of like safeguarding it. So in the same way, if you don't set a Boolean, or if you want to set it, you can set it to null, which means nothing. Zilch, nada. But let's just set it to true. Let's leave our lights on. And then turn them off. Okay, trying to think of more variables. Let's see, so we got our numbers, our text, and our logic. Sounds good for this episode. And you see, you can set, change, just like I showed you here. The data type, we have integers, longs, all of these, strings. Strings are most common, chars are used sometimes, booleans are used a lot. Then we have the name. We have all these names for our variables. Then we can set them to something, or you don't have to set them to anything if you don't want to. So thanks for watching and learning about these variables. Make as many variables as you want and play around with them down here. And I'll see you in the next tutorial.